Good day guys, thanks for joining us for another packet tracer tutorial. Today we have quite a complex situation happening here in which we have a few PCs, we have a router and two switches, and we also have a server and another PC. Right, so in this objective we're told to divide a subnet of 192.168.4.0.1 into 4 equal sized subnets. Right, use a second subnet for the green portion of the network. Right, use the fourth subnet and subdivide that into 4 smaller subnets, each with 14 hosts. Right, and put it for the yellow network. Right, using the first smallest subnet for the yellow network. Right, then we're told the router gets the first usable address in the subnet, the PCs get the 5th and 6th. Right, usable address in the green subnet, and the 5th for the PC in the yellow subnet. Right, the switch gets the first usable address in the subnet, and the server gets the 2nd address. Yeah, we're also told to configure IPv6 for the green network using the IPv6 address of 2001 db8:cccc:1 : and then we'll fill that with the respective letters for the router, which would be 1 PC0A and PC1B on the green portion. On the yellow portion, it would be router would be 1, the PC2 would be A, and server would be F. And right, and they're all on with IPv6, it's all on a /64 mask. Right, we also have to do a local link. They also give us some other steps here in which we will need to configure the switch configurations, right, with a host name, router 1 with a password length of 10 characters, username and admin account, encryption password would be Andrew Cadogan, console line, using console line data, login, enable password class or 12345 encrypted, right, password encryption on all files, banner message of the day, no unauthorized access allowed, domain name andrewcadogan.com, and SSH version 2. And we also have to set a timeout of 5 minutes on console, right, and PTI line. We also continue with security keys for RS module, router 1 with verified 04, switch 1, secure SSH access using local database, enable IPv6 routing on router 1, configure PCs. Well, we already spoke about configuring the IPv4s and IPv6, right, and network prefix and subnet mask and default gateways. I mean, all that is understandable. For switch 1 and switch 2, interface VLAN with IPv4 address and subnet, switch 1 and switch 2 default gateway, and backup router 1 and switch 1 and switch 2 running configuration on the TFTP server. Accept default name, right, copy run configuration to startup config. So as I mentioned, it's quite a lot, so we're going to get into this. So let's start running the cables using our copper for PC1 to the switch, and copper from PC2 to the switch. Alright, and same thing from the switch to gigabit 0 to the router, and on this side, which is going to be our yellow network, connect again, and cable from the server to fast Ethernet on the switch from fast Ethernet to 2 gigabit 1. Right, so I'm just going to put colors here so we can see which network we're dealing with. Alright, so we have the green and yellow. Right, so I'm going to start by configuring the IP addresses for PCs. Right, PC IP addresses 1 and 2, 168.4.69, right, Okay, so now we're going to configure on PC1 192.168.4.70 255.255 192. All right, now we're going to do PC2 192, which is a different subnet. It's 168.4.197. Mask of 240. Right, now we're going to do the server. The address is 192.168.4.194. right, and subnet mask of 240 as well. Okay, now we're going to set the IPv6 for PC0, which is 2001:DB8 :CCC:1 :A, right, and the subnet is 64/64 mask. Right, and for PC1, we just copy and paste, change the last letter B, and the default gateway is 1. Right, /64. For PC2, same thing. Change this to 2. Right, and /64. Just copy this and paste this here. The A, put 1. Okay, and we're gonna put the default gateway for IPv4, just 192.168.4.65. Right. Sorry, 193, not 65. Right, and we're just gonna put the IPv6 for the server. So that's 64. Valid. Okay, I copied and paste. So let's try it. Just typing it in. 2001:DB8 :CCC:2 F /64 default gateway is just gonna copy it here, paste, remove this, simple one. All right, so now we're gonna configure the router. All right, now we're gonna enter the terminal, enable, right, which puts us in executive mode. Config terminal, access, allows us to access global configuration. Now we're gonna enter the host for router 1, which allows us to set the device host name, right, and enable secret class 12345, right, to set the password for privilege exec mode, right. And then service password encryption, which allows us to encrypt all plain text passwords in our router's configuration. Right, so press enter. Username, admin security. Right, so we're creating the username for the admin, and we send the password to Kudogan and Android Kudogan. Right, and so now we're gonna set the banner to no authorization access. We just allow us to set the message for the banner, which appears to warn against unauthorized use. So no unauthorized access allowed. Enter. Now we're gonna set the router's domain name to Android Kudogan, to IP domain name androidkudogan.com. Right. And now we're gonna set the crypto key, which also generate the RSA key to secure communication. Right. Key generate RSA general /key modulus 1024. Right, now we're going to configure the router to use version 2 of the SSH protocol secure management. Okay, now we're gonna log in or set login for local username and password. Right. For 5 seconds. Okay, local login. Right, I'm just gonna take a timeout to 5 seconds. Now we're just gonna exit here. Right now we're gonna access the virtual terminal line configuration for line 0 through 4 for remote access to the telnet. Right. Login. Okay, now we're gonna enable transport input SSH, which restricts incoming connection on the line for SSH only. Right, set it to limit timeout for. Okay, so we just set the extension timeout for 5 minutes. Exit. Now we're going to enable IPv6 routing capabilities on the router, and we're just going to exit and write to memory. Right, so now we're going to configure the switch with switch 0, enable command to allow us to go into executive mode. Then we're going to configure terminal, right, and set the host name for the switch. We're going to enable the secret, the encryption password. Right, and I'm gonna set the admin configuration, set the banner, right, the local login, and the executive timeout. Right, and it's okay. Executive timeout 5 minutes. Exit. Right. We're gonna set the interface for the VLAN configuration mode and the assign an IP address for VLAN. Right, the IP address and the subnet mask of 255.1.2. Okay, we're gonna do a no shutdown to allow it, and then we're gonna exit. Right, set the default gateway. So IP default gateway is 192.168.4.65, and then we're going to exit and write to memory. Now we've completed the configuration for switch 0. Now we're going to move into switch 2. I'm just going to speed this up because the process is pretty much the same. Okay, so I'm just going to run an IP config. You can see the IP information here, right? So I'm just going to put the IP labels underneath so we know the IP addresses for each one of the machines. Right, and the server. Right, it's there. And I'm just gonna tag here for the IP address between routers. And so I'm just gonna do a ping test and ping PCs from PC0 to PC1 to see if we're getting anything successful. And the ping was successful. So now we're just gonna set the IP address on the router for the green side and the yellow side. That's the communication between the routers. So gigabit 0, IP address 192.168.4.65, default subnet mask of 192, right? And no shutdown. And then we're just gonna exit, and then we're gonna set the IP address for the other side. Sorry, I'm already in terminal. So interface gigabit 0/1. IP address of 192.168.4.193 and default subnet mask 240. Shut down, exit, and write to memory. Now if we go and check, we can see here that the IP address is set. So now let's do some pinging. Alright, so we're gonna ping, see if we can ping the default gateway, and we had success. Now let's see if we can ping the default gateway on the other side. And it's successful. Now let's see if we can ping PC2 on the other network. And we're sending it, and that's successful. Now let's see if we can ping the server 192.196. Right, and it was successful.